Hello, everyone. This is week 5 of your calculus summer preparations. This week we're going to go back to some of the geometry concepts which are going to be prevalent in calculus. So the first thing we're going to start off with is the concept of similar triangles. Similar triangles. This one comes up when we start dealing with some of the application problems in calculus. I'm not going to go into what those are specifically right now, but that's where this stuff pops up. So let's remind ourselves a couple of things about similar triangles. First of all, a similar triangle means it is exactly the same shape. So all of the angles, all of the interior angles are going to be the same, but the lengths of the sides could be different. And if that's the case, similar triangles are proportional to each other. Similar triangles are proportional. And the word proportional, the root word of that proportion, means that you're going to have some kind of two ratios, which are fractions, equal to each other. Okay, that's what proportional means. So, for example, if I were to tell you that 1/2 is proportional to 5/10, that should make sense. You guys know that 5/10 and 1/2 are exactly the same. Those two fractions, those two ratios are proportional to each other. Okay, same exact idea when it comes to doing triangles here. What it says is that the corresponding sides of the similar triangles are going to be proportional. So the biggest thing is you have to recognize, first of all, that you have similar triangles. Well, what we have here in number 1 is we have this large triangle that I'm going to go ahead and trace here in red. And then we have the smaller triangle, which is within that one. So part of this is going to actually be touching itself. So you can see how it traces over parts of the triangle. The one in green and the one in red are proportional to each other. They are the same, and that's because the angle here is proportional to the angle here. I'm sorry, they are equivalent. The angle here, well, it's proportional to itself. So we'll just put another little line there. And then the angle down here is equivalent to the angle in down on the bottom right. Okay, so in order to do this problem, basically what we have to see is, okay, we're solving for x and for y. Doesn't doesn't really matter which one we solve for first. I'm just going to go for x just because it's the first one that shows up. So in order for us to solve for x, I have to find an equivalent side. And by the way, this little arrow right here, hopefully you guys remember that that arrow indicates that those two lines right there are parallel to each other. And that is kind of an important concept as well. In order for us to do this, it looks like the side x is going to be proportional to the side 15. So x is proportional to 15. I'm trying to redraw that 5 there. That doesn't look so good. Okay, now we have to find one other side that's proportional. Well, the easiest one to use is going to be out here. This side, 6, goes with the smaller triangle, so it matches up with the x. And then the entire side of the big triangle, which is 6 plus 3, so that's 9, matches up with the larger triangle. So the biggest thing is to keep the bigger and the smaller triangles matched up as to where they are in the fraction. So the smaller triangle, I've put the values on top. The larger triangle, I've put the values on the bottom. Now it's just a relatively easy cross multiply and solve. So we're going to cross multiply the 9 and the x. We'll get 9x. Cross multiplying the 6 and the 15 is going to give us 90. So dividing both sides by 9, we get that x equals 10. Okay, and there's the first part. Okay, now we need to solve for y. We can actually use the 10 if we want to. We don't have to, but we could plug the 10 in for x now and use that as a part of the smaller triangle to figure this out. I'm actually not going to use it in this case. I'm going to stick with the fact that I know the entire right side of the triangle's proportion is 6 over 9. So I'm going to scroll down here. The entire right side is proportional 6 over 9. The entire left side, however, is a little bit different. The smaller side of the, the smaller triangle's piece is 10. The larger piece is the entire left-hand side here added up. So it's all of that, which is 10 plus y. Whoops. 10 plus y. So once again, it's a cross multiply, so I'm going to multiply the 10 and the 9, we get 90. Don't forget, when you multiply the 6 times the 10 plus y, you got to distribute the 6 to both terms. So that's going to be 60 plus 6y. Subtracting 60, we get 30 equals 6y. And then dividing by 6, we get that y equals 5. So there we have our answers. X is 10, y is 5. All right, we're going to move through this second one just a little bit quicker. Don't let the fact that the triangle's in a slightly different shape, like it's laying down on its side as opposed to maybe standing up. It just depends on how you view it. Don't let that fool you. Okay, so let's go ahead and find x first. The biggest thing is to find one of the sides that you can find both the small and the larger value for easily. Well, in this case, it looks to me like this side, I can find both the smaller value, which is the 20, and then the larger value, which is all of this added up, which is 26. So we're going to get 20 over 26, and that's going to be the proportional to. Now, if I'm trying to find x, I want to find the piece right here, which is part of the smaller triangle. So that's going to go on the top. And then the larger triangle is x plus all of this, which is x plus 9. Okay, same exact idea. We're just going to do a little cross multiplication. So we're going to get that 20x plus 9 times 20 is 180 equals 26x. Subtracting 20x on both sides, we get that 180 equals 6x. And then dividing both sides by 6, we get that x equals 30. Okay, now to find y, again, I'm going to use the 20 over 6. There's no reason not to use that, 20 over 26. No reason not to use that one. Small triangle over the large triangle. I'm trying to find y. Put that in orange over here. Trying to find this one, which is going to be a piece of the smaller triangle, so that goes on top. And then the larger triangle's base looks like it's 18. That's the one that matches. So now we're just going to do our cross multiply and solve for y. So we're going to get, let's see, 20 times 18 is 360. If I'm doing that, whoops, did not mean to select that one. 360 equals 26y. This one's not going to be quite as easy to do in my head here. Let's just go ahead and divide both sides by 26. Technically, that's y. We can reduce that. Both of these are even, so I know they're both divisible by 2. I'm not sure if there's anything bigger. Let's see. So if we divide by 2 on top, we get 180. Dividing by 2 on the bottom, we get 13. I'm pretty sure 13 does not go into 180. So let me just go back up here and double check that I did that correctly. So we have 20 over 26. That's the small over the large. Then we're going to have y over 18. That looks good. So 26y equals 18 times 20, yep, 3060. Okay, so that's it. Not a pretty answer, but that is our answer. So we've got y equals 180 over 13, and the x value was 30. Okay, I'm going to try and keep these all to about 10-minute videos here, so we'll come back with number 2.